Okay, hey guys, so this is the first problem and the second homework assignment. You get to analyze the truss shown below and find all the support reactions. So for this particular problem, there aren't any real tricks. You kind of just have to brute force your way through this. And because you have to find the largest member forces, and you have a kind of symmetric truss, but you don't really have any kind of you don't have symmetry like you do in this problem or in this problem, so you can't really take any shortcuts here. What we can do, so for this video, what I'm going to do is I'm going to show you how to refresh your memory on how to calculate reactions for a truss, and then I'll go through a couple, maybe one or two joints, and I think after that you should be good. So to calculate reactions, I'll just do one of the reactions. I'll do the Fy reaction. I'll take the moment about F, so I'll do the Ey reaction. And I think that once you, this is just a brief reminder. I'll try and keep this on screen actually. Let me see if I can just move it to the side a little bit. Okay, so in order to find the Ey reaction, right? So Ey, I'm going to take the moments about F. I don't have Fy yet, so I can't do sum of forces in the y direction, but once I have Ey, I can just do sum of forces in the y must equal 0, solve for Fy directly. I already have that the sum of forces in the x direction must equal to 0, and I only have one term in the x direction. So I know that Fx, or the reaction at F in the x direction, has to be equal to -2, or Fx will be equal to 2 kilonewtons going to the left. To calculate Ey, I'm going to do my sum of moments about F. And for this, I'll just say that, let's say that clockwise is positive. And if I do that, then I'm going to have, remember for the sum of moments about F, I do force times distance for all the forces that I'm looking at. So for E, I only have force in the y direction, right? So I do Ey. Let me do a new line here, Ey times L. And then I have this 2 kilonewton force that's acting in the clockwise direction. So I have 2p times L, times 3L on 4. I have this p, which is acting downwards at some distance L. So I have minus p times L. This force 2p is in line with F. So essentially I could say that this is 2p times 0. So I can just practically ignore this one. And then I have this force at the end. So this is p times L, and it's acting clockwise, so plus PL. And if I do that, I will find that if I reduce this down a little bit, that this becomes 1 on 2. So I should get that Ey plus 3p on 2. I can cancel out the L's here. Plus 3p on 2 minus p plus p. So this goes to 0. And I should get that Ey is equal to -3p on 2. So note that this force here is actually going to be downwards. It's going to actually, because all the forces acting on this want to rotate the frame about, or rotate the truss about F, the reaction at E actually has to hold the truss down to prevent the rotation, so you actually get a reaction that's going downwards like this. So that is your reaction. For the 2 points, let's do the joint at G first. I think that one's the most straightforward, and that'll give you a good overview on how to do truss analysis. So if I go back to my truss, for example, I have, this is G, I have some force P going down, and then I have some force here, which is, I'll call that FGF, and I have some force up top, I'll call that FGB. Note that my notation, I'm drawing my arrows away from the joint. In other words, I'm assuming that all my beams are in tension, and that helps me later on, because if I see a negative sign, then I instantly know that it's compression. I personally prefer to just draw my arrows like this, always in tension, because I don't want to have to go back later on and say, well, did I actually draw this arrow in compression or in tension? And if I'm consistent with all my notes, then I don't have to worry about the signs later on. I can just look at the sign and say, oh, that's positive, therefore it has to be in tension. So here I have this. We have our triangle looks like this, right? This is L, this is 3L on 4. If I call this theta, then I'm going to find that my sine theta, and let's see, I thought I have some notes here, and I thought I had written this down already, but my sine theta, I'll find that this one up here is actually equal to, I believe it's 5L on 4. This length up here will be 5L on 4. Sine theta is just opposite of my hypotenuse, so sine theta will be equal to 0.6. Cosine theta will be equal to 0.8. And you can just show this very quickly. So for this one, if I do sum of forces in the x direction first, so sum of forces in the x direction, I should get that FGB times cosine theta, this will be negative, minus, sorry, my coordinate system is like this, x, y, minus f gf cosine theta equals 0. In other words, because my cosine thetas would cancel out, right, because they're equal to each other, my FGB is equal to negative FGF. So I know that these two will have the same magnitude and opposite signs. If I then use my sum of forces in the y direction, I should get that FGB sine theta, and it's positive this time because the arrow is pointed upwards. So that's positive. This arrow is pointed downwards, so this is negative, minus FGF sine theta. This arrow is pointed downwards, minus P equals 0. And if I solve for this, I can plug in one of these two equations into here. Right, so for example, I'll plug in negative FGF into here. So I will get negative 2FGF sine theta minus P equals 0. I have sine theta is equal to 0.6, so when I plug this in, I get negative 1.2 FGF equals P. I just brought the P to the right-hand side. Therefore, FGF is equal to negative, or sorry, is equal to negative 5 on 6P. And I also therefore have that FGB is equal to positive 5 on 6P. So one last comment on signs. I have it written down here that negative P, and I have negative 5 on 6P, positive 5 on 6P. So at the very end of my work, I would just summarize this. So I would say that FGF, for example, is equal to 5 on 6P compression. I would either summarize it like this, or I would say at the very beginning, or for example, if I would either do this for every single force, or I would say that FGF is equal to negative 5 on 6P, and I would make a note at the top that compression is negative, tension positive. So you can do one or the other. Please don't do both. So if you're gonna say that tension, like, well, I guess it doesn't really matter too much. But there are some cases where people will put, for example, negative 5 on 6P compression, and this doesn't make this, like, this is conflicting, right? Because normally you indicate what your positive represents. You don't indicate what your negative. Like by putting this compression sign next to this, you are saying that, like, you're normally saying that this is your positive sign convention, right? Because normally you would write it down like this. If you would instead put FGF equals negative 5 on 6P compression, then this can raise some confusion. So do one or the other, not both. Okay, let us know if you have any other questions on this first problem.